Hello, community! Great that you are back! Would you like to step in? You know, in my last video I was talking here about Firebase Studio, and I'm doing here on my first day, I'm doing here all my beautiful tests here with Firebase Studio, and I'm coding, I'm building my app and have beautiful ideas. I can integrate here agent into the app via buttons, and it is just great. And then suddenly I notice I am trapped here. So if we open up this video, you know, it's easy. What I see also here, what we have is classical. Now, we have a beautiful prompt, and then people say, yes, I have rack systems, and I fill up this prompt with data. And I don't want to talk here about the lie by Meta about the 10 million token context length here from Llama 4's CoT. Just let's go with 128K or 256K, whatever you enjoy. So your rack pipeline fills in data, and you think this is great because now you extracted here from hundreds of books here the relevant paragraphs, and now the AI can do the work for you. And the idea is, let's say we stay with this simple visualization. All these water molecules that are now in our prompt, those are the building stones here for our chain of thought reasoning. They are here the elementary reasoning. They are the elementary data that we can reason on them. And what we imagine, and me included here, this idea of a network, the AI does complex reasoning now, and the AI has so many reasoning paths it could go forward, so many data because you filled up here with RAG, all the data available, and you know that this is not the reality. Because the reality, and I see this every single day when people ask me, you know what they do? They have here, they fill up this data, and they have, let's say, financial data, and absolutely beautiful financial data, and they want a financial prediction. So if you look now at the data, they have their data, and they want a prediction, but they are missing here the bridge to this prediction. And I ask the people, why? What do you imagine? How should this be possible? Because all the data that you fill in that are historic data that are great, but now you say you want a new investment strategy. You want something completely new that we have no training data on, a system that is unknown to us, and you want here that the AI comes up now with a new system configuration for evaluating the financial risk for your data. And you think now that, just do chain of thought, But the reality is this data are missing. And the idea that the AI has a secret formula to connect both data agglomeration via a chain of thought, I think this is the trap. Everybody steps into this trap. Independent what level you talk to. The idea is you have an AI agent, you have a large language model, a vision language model, and this model is a general intelligence. So you just fill in nonsense data, historical data, and you say, what I would like to have is a performance of 26%. But you don't provide here theorem, you don't provide bridges, you don't provide here any data that the system could try out. So this idea, this AI, this artificial intelligence, I think this is a mindset that is so wrong. And I tell now everybody, imagine AI is just a 5-year-old child. And this is the way you have to treat it if you have input data. Because you know what? In reality, the context here is not in the training data. And you think, hey, well, if I buy here a beautiful OpenAI LLM, it must be in the training data. It has been trained on a complete internet data, on trillions of tokens. I'm sure there is some financial, theoretical, abstract. No, it is not in the training data. And if you don't provide this, either in your supervised fine-tuning or reinforcement learning or whatever, and you have thousands and thousands of examples, it is not in the training data. And therefore, you can hope for a chain of thought, but it is not going to happen in reality. Great. So if you think here, chain of thought, step 1, step 2, these are our chains, no? And then you have this here missing. You immediately understand it is not possible to put here some weight on this chain because here one chain element is missing. Now people do something beautiful. The humans are really creative, no? And they say, you know what? I take here a thematic clustering. Okay, I try to understand whatever RAG brings me in, no? I do a thematic clustering, a subclustering, yeah, in multiple dimensions, yeah. I have people that tell me, hey, you know what? I go here into the mathematical vector space and I do there an embedding clustering because the intelligence of the AI did here an embedding structure that put relevant elements right next to each other. So I just have a look at them and then I try to deduct here how to build bridges. And you know what? They all fail. And it is simple. Now, solutions are easy. If you know what it is, you know, I tell them, hey, train your LLM on one specific task. Slowly increase the complexity of this task and you will have no problem at all. Make sure you have a predefined set of input parameters for your one specific task the LLM has been pre-trained, supervised, fine-tuned, reinforcement learning on, and you know you have a minimal set of parameters. And then you can have more parameters, beautiful, and you can have the whole financial theory to this, beautiful. You know maybe more than I do about financial mathematics, but always check for this minimal data input in your pipeline, in your data pipeline. Because if you lose one of the financial parameters, you can have the intelligence of the world in this AI model. It will not be able to build a chain of thought reasoning. Or, and you remember here my last video, I showed you Google's new ADK, and we had here the root agent with two sub-agents, you know, the greeting agent and the farewell agent. And now you know what I do. I build now agents that say, hey, I have now, if you want step-by-step reasoning, I have here the first reasoning block, and I just make sure what are the input parameters. And then I have another agent. If I go to the next reasoning block, what are the input parameters here? What are the output parameters here? And then I just compare them. And I make sure I'm not missing one of the critical parameters for a financial theorem that you want to apply for some financial forecasting or weather forecasting or medical, whatever. It is so simple, the mistakes that sometimes can happen. So solution 2, train a new AI, train a new agent, two agents, who cares? To check the logical dependencies if you go from one logical step to the next logical step, you know, in your chain of thought. Just make sure that you understand what are the output parameters of the first step, of the first reasoning block, if you want. And then what are the input parameters? And if you see the input parameters here have a new component C that is not in the output of the other linear chain or of a tree structure, where the hell do you think C should come from? And now something beautiful happens, you know, in this AI system. Because the LLM is trained on a specific chain of thought structure for a specific user query. In the training data and whatever reinforcement learning, the LLM trained, hey, if I got this particular financial task, I know that a specific chain of thought structure in my training data that was given to me by the humans, this is the solution they want. And I have to go through 3,000 reasoning tokens in a specific sequence. And now the LLM is applying here the chain of thought structure to this problem where there are one parameter missing. Now you might say, and maybe I might have said before I record this video, now the LLM starts to hallucinate the value, the integer value, whatever you have of C. Because the LLM is trained to run this, to build this chain of thought structure, let's say 3,000 token or whatever it is. But there's one tiny little element missing. So what the LLM does, it hallucinates because it has the imperative build the specific chain of thought structure you were taught to do in your training data. And you know what is the beautiful thing? You can see this from a different perspective. The LLM tries, now let's do it a little bit from the human side. Let's be a little bit empathic to our AI system. The LLM tries to run this chain of thought structure. And I said, damn, I'm missing C. You know what? And now the LLM uses a kind of a default C. And this is what we do in coding, no? Sometimes we have default values. Should something happen, you have a default for the temperature, for the plasma temperature, for space curvature, whatever you have. And now the LLM tries to use this default C, but it is not there. So now the LLM searches for the value of C to run its specific structure. And guess what? We are in an autoregressive system, so therefore just looks here, hey, where is my probability distribution? Where is C? And given you a specific training data, the LLM will find somewhere, it will find accidental, any value of C, and it will integrate C into the specific chain of thought structure. So now you understand exactly how you can prevent maybe hallucination, but for sure, for a trained chain of thought structure, you have to check that you have all the parameters in place for the LLM to perform its job. And you might say, yeah, but come on, this is just what you imagine. And you are right. If I would not have read this report, and this is a report here from India, and I pick it up because I think beautiful. I have not seen a lot of reports here in AI India, so I want to show you this here from my colleagues here in India. I've never been there, just found out here, this institute here, KIIT, here's the 6th university positioned among the Indian universities, so beautiful. And they did some study. And they took here the effort and they had some real human data. And this is always great if you apply human data and real world data and you do an LLM prediction. Yeah? And you have an LLM and human expert. And they just compare what is the performance here, the diagnostic performance of an LLM to the human expert diagnostics for a particular disease. And the disease, let me check, it was nothing deadly, arthritis. Okay, so whatever, never mind. And you know what they found? And they, authors now say, our study now highlights a clear misalignment between the LLM's high prediction accuracy and its flawed reasoning. And if they say flawed reasoning, I will show you it's really flawed. It's a catastrophe. And they say, this raises now the important question about relying on an LLM explanation in the clinical settings. Because they now write, the LLM provides the wrong explanation and the wrong medical, clinical, analytical, performance, although they have a high accuracy. Now, from the latest report here for Anthropic, we understand that this chain of thought reasoning that we see in the reasoning model is not really the reasoning of the model itself. This is just something the model shows us because it was trained to show us something. And I think this is so beautiful that we see this here in a study from April 9, 2025. Beautiful, our colleagues here in India. Thank you for this study. Look at the data they give us. So they have a Gemini 2 and a GPT-4, never mind, and they have now an LLM without a RAG, an LLM with a RAG, and then 2 agents and 3 agents with RAG. Now, here you have in this color here the accuracy, 90%, 100%, 90%, 60%. That's interesting. The more agents you add, the accuracy goes down. But LLM without, 90%, LLM with RAG access to a medical database, 100%. Great. It was a simple medical task. There's nothing exaggerated. But now look here on the reasoning. So the prediction is high, beautiful. But now look here, the reasoning, as checked now by the humans, the LLM chain of thoughts, was correct only in 10% of the cases. In 40%, the LLM reasoning had major flaws. and another 40% it had minor flaws. So whatever means minor flaws in medicine, you don't want major flaws, and I don't want minor flaws in my medical report. Now, if you put in the direct system, beautiful, the LLM had access here to this external data sources here, and increased here 40% correct. But why the hell did a 40% stayed exactly in place with major flaws in the argumentation of its finding? It's fascinating. Look here, the same thing with a GPT-4 Omni. We have 40%, so higher in general. So this system here was maybe trained on this medical data that are somehow related to this disease, without RAG 40 and with RAG 40. And just the major flaws went down from 30 to 20, but then the minor flaws increased. I think it's absolutely fascinating. There's a second topic if you just look at the performance of two agents, but that's not really our topic today. Just want to show you, even with 100% performance prediction accuracy, the internal reasoning that we get out here of a reasoning model is only to 10% correct or maximum 40% correct in this study with real human patients, with real human data, with real human doctors evaluating here the chain of thought reasoning of an LLM. And I think this is a study, it's beautiful. But you know what? There's another study. Yes, that's more to the point, that is more powerful. And this is here, University of Maryland and Lehigh University. And they, April 9, 2025, they look now here, are reasoning models, AI models, losing their critical thinking skills? And this is now fascinating. This is now absolutely fascinating because they have data that is cool. Now, I just want to give you the result that you can smile a little bit about it. Yeah? So we have a non-reasoning model, and then we have a reasoning model. So here you don't have to wait for the answer, and here you have to wait, I don't know, half an hour for the answer. So they go, hey, what is the value of A? And the model, the non-reasoning model, so the more stupid model says, hey, please provide the context you're working with. You know? So it says, I have no idea what you want from me. If you ask an advanced, expensive, huge, humongous reasoning model, hey, what is the value of A? This reasoning model has been trained to, I don't know, here in this case it uses 8,000 tokens, close to 300 seconds, to tell you, the user might want, hey, perhaps, maybe, since, I don't know, maybe it's possible, alternatively in chemistry and biology, maybe if this is the case, I have to revisit the question again, the common way, but I have to give an answer, then the value is 2. So what happens, this reasoning model was trained to do this long chain of thought reasoning, and it spent 8,000 tokens to a question, what is the value of A, when nothing is given. Neither A, neither a value, neither a context, neither nothing. But it produces 8,000 tokens. And that's what they call overthinking. Now it gets even more interesting. If you have now the reasoning model, we stay with the reasoning model, and we have a simple task. Now we say, listen, James decided to run 3 sprints 3 times a week, so 9, and he runs 60 meters each sprint. How many meters does he run in a week? So 9 times 60, 540. Great. Now we do the same, but we are now, we say, missing premise. So what we do, we just delete one sentence that is absolutely essential for the solution. Now, you would say, hey, if you tell me, hey, he runs 3 sprints 3 times a week, how many meters, you have to give me a reference, no? But you know what this reasoning model does? This reasoning model now spends 1,742 tokens trying to argue around alternatively. Maybe the user wants, however, tricky. The common definition, check again. Running around in circle in its reasoning because it is missing central important information. But it is not saying, hey buddy, I'm missing information. I have one set of data missing. No. Overthinking happens. You produce an explosion of tokens. You wait 85 seconds for the wrong answer. Isn't this beautiful? This is exactly like my images I showed you at the very beginning of the video, no? We have the data set with 3 sprints and 3 times a week, and we have James, and it is beautiful. And then you want here not a prediction, but here a mathematical operation. How many meters does he run in a week? So we are here in the second data group. But the bridge connecting our 2 data agglomerates is missing. This sentence is missing. And the AI does not get it. No, this is wrong. The AI has not been trained to say, hey buddy, I'm missing data from you. But the AI tries to find a solution. Interesting. They have different strategy how to create this question. Just think, they just remove critical premises that are necessary, absolutely necessary for a logical resolution. No way around this. Now, let's look at the result, because I think it's so beautiful. They tell us here, this missing premise in our question leads to, in these reasoning models, 2 times to 4 times more token, overthinking, contradicting now this beautiful test time scaling law, because it's just thinking pure nonsense. Instead of telling me, hey, missing data, stop, it is trained to go with its huge, humongous chain of thought reasoning. It is entering then self-doubt loops, repeatedly visiting the question, guessing the user intentions under this missing premise, resulting in an explosion of tokens for nothing. So we can say now, hey, something is definitely wrong with our reasoning models if those models do this. And you might say, yeah, but maybe just one LLM, no? And they made a beautiful study from QWQ, here Stanford S1, DeepSeek R1, DeepSeek R1 distilled, Q1, O3 mini, O1 mini GPT, and they had here the reasoning models on the left side and the non-reasoning models here on the right side. Now, let's just look here at this red line that goes up here. So for the reasoning model, the question is the abstain rate for missing data question. When did it abstain? QWQ 10%, Stanford 16%, DeepSeek R1 16%, O3 mini 23%. So it tried to solve it. It didn't say like a non-reasoning model with more than 50%. Hey buddy, data are missing, stop. It tried to solve it because it was trained to provide a chain of thought and a solution. And then we look here and you see here in orange here how many response tokens were created here, 5,000 tokens. 5,000 tokens, pure nonsense, for a question that is missing one central fact. And then in blue we have here the amount of token in the answer for a well-defined question that is not missing any data. So you see, if you have less token in the answer, you see here, independent of the model you go with, correct input data lead to shorter reasoning tokens. If you have an explosion in token here, Stanford S1 model, more than 5,000 tokens, trying to find a solution to a data problem where it's simply missing input data. But the AI does not understand it is missing the data. And I think this is the reasoning problem and the AI trap, that we believe the AI is intelligent and the AI will tell us, hey, I'm missing data. No, the AI has a different training algorithm. It was not trained to tell you, I'm missing data. And the authors come back and says, hey, this demonstrates here this overthinking, and it is both in the reinforcement learning based and in the supervised fine-tuned based reasoning model. So if you go with only reinforcement based training or with only supervised fine-tuning, it doesn't matter, it happens in both. And they now, here in quote, the authors tell us, hey, we hypothesize that this phenomenon probably originate from inadequate length constraint during the reinforcement learning based models, and then it just propagates to the supervised fine-tuning models through a model distillation. I don't know if this is the real reason, but okay, this is what the authors tell us. So they say must be something in the reinforcement learning. We do reinforcement learning wrong, and just if we use then distilled models with supervised fine-tuning, it's just in the distillation, of course, cannot create something new. Interesting to see this. So let's come to an end here. This overthinking is a critical drawback in the reasoning models that we have. And they looked at quite a lot of reasoning models, and they found it in all of the reasoning models that they examined here. So there we have it. This critical drawback in the reasoning model is not the fault of the AI system. It's not that the reasoning breaks down, but just we as humans are not intelligent enough to provide here a query to the AI with all the input data that the AI would need to solve the query. So we think somehow this is such an intelligent AI system that it will just do, I don't know, just imagine here the correct number for the plasma temperature or for a financial transaction time period. No way. So it is the human error here, not giving enough specific input data for a specific query. And then it happens that the LLM trying to solve our query starts to hallucinate. And maybe I would say it doesn't start to hallucinate. It's just trying to find numbers for the missing data that we failed to give it. And therefore, maybe the amount of hallucination is much less than we imagine. It is just that we don't understand that we do not provide here the minimum data set here for the query to be solved. Interesting. Absolutely fascinating. It is mid of April 2025, and now we discover it is more or less our fault. So don't step into this AI trap, because you will not find out what happened and why it happened, and you look at the wrong partner. It is not the AI. It is just your input data that are simply missing for your specific task. If you enjoyed it, hey, why not subscribe, and I'll see you in my next video.